Hello everybody, welcome to ConvergeML, and in this video I'm going to talk about some of the top Python libraries that was posted by Data Science Dojo this morning, which linked to a graph which was originally done by KDNuggets, and I found that graph really, or that picture really interesting. I'm going to talk about that picture and also talk about some of the libraries that I use from that picture and how do I feel about them. So let's get started. So here we are on the KDNuggets page, and there is a picture that I'm going to show you in a moment. And it was posted, as I said, on LinkedIn this morning, and I found that interesting. It's called the top 38 Python libraries for data science, data visualization, and machine learning, November 2020. Now, again, this is not very old, but also it's been, I would say, it's been nearly almost getting there for a year, about 10 months. But I wouldn't say that a lot of things would have changed for the things that have been mentioned in that picture. I would definitely say that there are some additions that I would like to make to that, but let's just take a look at it, right? Without killing any further time. All right. So number one, again, it says top Python libraries for data science, visualization, machine learning. And here are the colors, and those colors and shapes represent if they are AutoML or they're data, libraries dedicated to data, explainability, mathematics, machine learning, or visualization, right? So those are the sort of the types of packages or libraries they've looked at. And I'm going to talk about the ones that I find interesting and also the ones that I've used personally, so I can make my own, I can sort of comment on those, right? So the first one that I would say, and that's probably the most interesting one, where anyone's eye would go, is looking on this right-hand side. Now, before I talk about about these packages, so what we have is on the x-axis we have contributors. Now, this is talking about contributors to the contributors on GitHub who are building this library, right? So this is the number of contributors to that library. And on the y-axis, we have number of stars. So talking about how popular that library is. So how the popularity on the y-axis, and on the x-axis, you have the people who are actually working towards making that library work fluidly, fixing bugs, making sure they add features to it and things like that, right? So getting into it, we have on the far right, we have 3 libraries. Now, 2 of those are coming from data, right? And the star, so that is the machine learning, right? And so we've got scikit. So scikit, of course, as we know, is a really popular machine learning library. It's great for regression, classification, unsupervised learning, dimensionality reduction, or even data pre-processing. So it does a lot of great stuff. So it's really a really good machine learning library. Then we have, in terms of data, we have pandas. Pandas is in-memory data frames. Again, really familiar sort of API if you're coming from the world of, not the API, but if you're coming from our world, you know what a data frame is. It's just basically a table, or even think about Excel table, right? That's what a pandas data frame is. And it's really, really good. It's probably bread and butter for anyone who is in Python trying to analyze data or any tabular data. So yeah, it's great. Then we have Apache Spark. So Apache Spark, again, this one is big data, right? And Apache Spark is something that I use a lot. Again, Apache Spark is written in, I would guess it's written in Scala. But the things that I basically use is not in Scala, but in PySpark. Again, a really good library. It scales really well to big data, and that's what it's made for. It's really sort of good to see that it's sort of one of those high contributing and also highly liked library, which is indeed the case. I would say the same for that. Okay, so if you just come to this part, which is coming down with around 1,000 contributors and about, I would say, around 15,000 odd, stars. We have matplotlib. Matplotlib is, again, a visualization library. It's, again, bread and butter for people who are actually doing visualization. In Python, that's the first library that you learn. If you come from MATLAB, matplotlib is where it sort of has its origins. But again, it's a really good library, something that you learn when you're starting off. Again, we have right here in the bottom, we've got SciPy, which has, again, very, around 900, I would say, contributors and about, I would say, 7,000 stars. SciPy is, again, a really good library for optimization, statistics. It has a really good, it's a really good package. And SciPy at one point had stats models as a part of it, and stats model then became different. Like stats model came out of SciPy. I think that was about in 2009 in Google Summer of Code. But anyways, SciPy is really good. Again, we have NumPy, bread and butter for pandas, because everything sort of that you do in pandas, the basis, of course, is NumPy. And NumPy also has, when you're doing deep learning, so PyTorch talks a lot of NumPy. So yeah, I mean, I think NumPy is also a really good library, a really famous one, but it looks like it doesn't have a lot of stars, which is very surprising, if I'm really honest. Anyways, we then have, if you go again, if you just keep coming, I actually haven't used Apache Superset. I'm not sure. There's XGBoost. XGBoost, again, a machine learning library. It's a great library. Apparently, you can also use, so although XGBoost you could use like with pandas, you could also use it with Apache Spark. And I found that, so if you go to XGBoost, so let's just go to XGBoost. I was just looking at this. I think, yeah, XGBoost 4J Spark tutorial. Now again, they're trying to sort of merge it with Spark MLlib. That's what they say here, and make it like a distributed way of doing modeling, right? So it also has that sort of feature, which is really exciting. All right, we have Bouquet. Bouquet is, again, a visualization library. It's a bit different from Matplotlib because it has got interactivity within it. Again, a good package. You could create some dashboards and stuff like that. So yeah, it's really good. Then we have Dask. Dask is, again, for big data. I haven't used it, but yeah, a lot of places when you talk about Apache Spark, you talk about Dask as well. Then you have our lovely friend here, Stats Model. Stats Models has its a lot of there are features in Stats Model, for example, time series that mostly people gravitate to. And when they do that, they sort of go to Stats Models to use its machine use it time series capability. Of course, it also comes from statistical background, so it has a lot of statistical tests, and the summary has like p-values and stuff, and p-values and confidence intervals. So yeah, so it's a really good library as well. I will have a video very shortly talking about differences between stats models and scikit. So by the way, if you like the video till now, where we're going with it, please like and subscribe. It will really help my channel to grow. So yeah, all right. Let's move on. So we've got another one, which is CatBoost. CatBoost, again, is a great package. This is, again, very similar to XGBoost. These are grain boosting libraries. XGBoost, it's a really good library, but it works really well with smaller data sets whenever I've experimented with it. So if you're using really small data sets, and want to bring like the greatest value from that, use CatBoost. Just definitely try. Okay, we've got LightGBM as well. Again, a really good one. I would say CatBoost, LightGBM, and XGBoost are like, there are a lot of comparisons between these three libraries. But I think XGBoost was the first one to sort of come out, and then it followed with Light GBM, and then I think CAD Boost, but I might be wrong. Anyways, moving forward, we've got Plotly. Plotly is again a great library, and very similar to like you can create dashboards and stuff like that. It has a lot of interactivity with very similar to like Bokeh, but also Plotly is used in Dash, which is a dashboard sort of framework. It's a very comprehensive framework, very similar to R Shiny. So I would definitely tell you to check it out. It has a lot of great statistical and interactive features like maps, all kind of statistical graphs that you can think of. And so yeah, I wouldn't talk a lot about this right now, but yeah, Plotly is a good library. Check it out. Then we have Seaborn, of course. A lot of that is coming from Matplotlib, a really good library. H2O, I haven't used it, but yeah, it looks to be very. I mean, it looks to be like it's very down. So yeah, I didn't expect that to be. With such fewer contributors and fewer stars. But anyways, I'll leave it there. I haven't used H2O. There's Altair. I experimented a little bit with Altair. Altair seems to have more natural sort of API to building, building visualizations. I will definitely recommend to check it out. I did it. I liked it, but I haven't started. I didn't sort of start using it like for my projects. Then we have, I'm picking and choosing here. We have Prophet. Again, Prophet, not a lot of contributors, but Prophet is a really good library for time series. I've used it, and at some point, I believe I did a little bit of like an applied sort of research on this to present back to my team. As to how we can best use Prophet with all the functionality that it provides. It uses Stan at the back end to build time series, and has like an additive nature of so that you've got a linear model, you've got seasonality and trend, and all of that sort of stacks up, and you can introduce a lot of pretty cool features within the model. But again, I will recommend using Prophet if you're using time series. There is Shap. Shap again, people who are building models, you would know Shap is a really good library for model explainability. So yeah, if you really want to understand how your model is performing, especially if you have like a tree-based model, like a black box model, where there are a lot of interactions happening, and you really don't. You can't really easily spot that if you are just trying to build some if you're using, of course, some basic visualization to understand the model. Also, if you're using some other libraries like Lime, and they have their own shortcomings, but Shap is sort of a very consistent sort of framework that gives you really accurate explanations for your features. And so yeah, definitely check that out. It really has cool visualizations as well. I mean, it really helps you to understand your data, and we use that regularly for our models. Then we have Optuna. Again, Optuna is used for hyperparameter tuning. Hyperparameter tuning, and again, it's a really good library if you want to. So you definitely, if you're using scikit, you definitely have like grid search, the random search, and all those sort of searches that we have. But Optuna provides you a little bit more of a boost to that search. So I'll definitely recommend Optuna. I think uses as a backend uses PyTorch to it. But again, I would highly recommend this. Now, I haven't used these, if I'm honest. Teapot I've heard of. It's automatic machine learning, so there's definitely there. One thing that I would definitely point out, it's probably not here, and someone mentioned it in the comments as well. So if you just scroll down, someone mentioned in the comments that I think you missed PyCaret. PyCaret again is a really good library for AutoML has again, has a lot of, so basically you give it a data set's going to fit server models and tell you what is the performance of those models, and you can easily understand what sort of model will work best for your data. So yeah, I would leave it there. I hope I was able to give you some insight about all these libraries and the ones that I've used and the ones that I like, and hope that makes sense. If you liked it, please like and subscribe, and I'll see you in the next video. Thank you. Bye-bye.